This is midterm number 3, practice midterm number 3. Problems 3 and 4, I'm going to do these in one group because they're pretty much about the same thing, just different aspects. And problem 3 is rank the following 3 compounds in order of increasing carbon-carbon bond length. And I've underlined the word increasing because on the test, I may have you rank it in order of decreasing bond length or increasing bond length. There'll be some sort of problem like this to ask that question. So please note that when you get the actual test. On the practice test, you'll understand why, and on the actual test, you may pay particular attention to whether it's increasing or decreasing. And question number 4 is rank the following compounds in order of decreasing carbon-carbon bond strength. And I've got the same 3 compounds, and the compounds in both questions are depicted as a single bond, H3C, with a line connecting it to CH3. So it's a carbon-carbon single bond. The next in the given questions is a carbon-carbon triple bond with HC triple bond CH. This is acetylene. And the last one is a carbon-carbon double bond with H2C double bonded to a CH2. Ethylene, acetylene, and ethane, if anybody wants to know. And so these are the 2 problems. So let's handle problem 3 first. And what we need to know is what is the correlation between between bond length, it doesn't matter what kind of bond, the bond length and the bond order. And so here I've got a single bond, a triple bond, and a double bond, what is the trend as we increase the bond order. And it turns out that as I increase the bond order, there's more bonding interactions, more attractive interactions. And so the higher the bond order, the shorter the bond. A triple bond is shorter than a double bond, and a double bond is shorter than a single bond. So in order of increasing bond length, the triple bond would be the shortest. So it would be I would depict it with the carbon-carbon triple bond first, writing it in the same way it was written on the test, is shorter than or less than the double bond, which is going to be H2C double bond CH2, which is again shorter than the single bond of ethane, which is H3C single bond CH3 in our notation. So I end up with this sort of an ordering. 1, 2, 3. Triple bond shorter than double bond shorter than single bond. And it's a very simple question. This is gimme points on the actual test. I don't expect anybody to have a problem. Having done that, let's now answer the same problem in terms of bond strength. And the logic here is pretty much the same. The higher the bond order, the stronger the bond. A triple bond is stronger than a double bond, which is stronger than a single bond. So the lower the bond order, the weaker the bond. And here I want to rank it in terms of decreasing. So that means I'm going to start with the strongest bond and go to the weakest bond. So again, the strongest bond is the triple bond. So I'm going to end up with, I'll draw acetylene first. HC triple bonded to a CH in a southerly. And that is stronger than, so I'll say greater than the double bond, which I'll denote with an H2C double bonded to a CH2, which is, again, stronger than a single bond, which I'll denote with an H3C single bonded to a CH3. So that notation, which is consistent, answers this question. What I would expect to see on the test would be this. You could depict it with a 1, 2, 3, and by simply labeling this another way of denoting it on the test, and I've seen it done this way as well, and I'd accept it as long as you're clear. In order would be, this would be 1, this would be 2, and this would be 3. And if I use that notation above, again, this would be 1, this would be 2, and this would be 3. I would consider either approach to be acceptable. So you have that much latitude. But you want to pay particular attention with this one to the words increasing and decreasing. The logic is pretty straightforward. Okay, is that all the information?